All right, why don't we go ahead and get started? Welcome to the North Central U.S. Climate and Drought Summary and Outlook for August. We do this, as you know, every month on the third Thursday of every month at 1 p.m. Central Time. My name is Doug Cluck. I used to work for NOAA. I want to thank the National Drought Mitigation Center for hosting these, and as well as Dennis Toddy, who's on the line with us as a partner from the USDA Midwest Climate Hub. And our speaker today, Zack Leasor, who is the state climatologist here in Missouri. I say here because I'm in Kansas City, and he's in Columbia, obviously. Other thing I wanted to mention really quick is we will take questions as we go through this. You can, if something pops into your mind, type it into the question Q&A place at the very bottom. You can click on that and ask anything you want. And then we'll get to those at the end. We may answer some of them as we go. And anyway, Zack, are you ready?
I think so. Thank you, Doug, and
Thank you.
welcome everybody to the North Central U.S. Climate and Drought Outlook August 2025 edition. And my name is Zack Leasor, and I'm here at the University of Missouri as state climatologist, and that's where I'll start us today. This picture was actually taken by an undergraduate student who works here in the Missouri Climate Center, Thomas Schwent, and it's a late summer sunset across campus, and a pretty quiet evening. I think this was a few weeks ago, and as we get into August, not as calm for this kind of setting here on campus. And so before we get into things, definitely want to shout out some groups for providing information, not just for this webinar, but all of the webinars. And that includes state climatologists, various NOAA groups, the USDA climate hubs, the National Drought Mitigation Center, and the Midwest and High Plains Regional Climate Centers that cover the central region here. And both of those climate centers, they do provide an archive to the past recorded presentations and will be the future home of today's presentation as well. So this will be our August outlook. Next up will be September, and we'll move east, and Dr. Trent Ford, the Illinois state climatologist, will be the September presenter here. And so a little agenda here today. This is a supercell that was sent from Watertown, South Dakota, a really beautiful structure on the storm, and we will definitely be talking about some of the severe weather across the plains as part of our recent conditions and impacts. But we'll start by really just looking at the past month or so, some of the impacts from the climate conditions that we observed, but then we'll also end with a look ahead at some of the outlooks and then get into the Q&A that Doug mentioned as well. So to start us right off, let's take a look back at July here. And this map shows the statewide average temperature ranks for July 2025. And so anywhere you see a state shaded red, saw above average temperatures. We don't have any blue on the map, but that would be below average. And then that white color is near average. And so we see for a lot of the central region, warmer than average temperatures were pretty common, except for out into the west and the high plains where more moderate temperatures were seen in July. But basically, the farther east you go in the region, the warmer it was relative to normal. And we see July in Kentucky, most noteworthy in the region. They had their sixth warmest July on record, and that goes back to 1895 here. But if you're looking at that map of average monthly temperatures and think, it felt a little bit warmer than that during July. You might be right, because there's a little bit more to the story here. And so that was our overall average temperature for the month. These are the same maps for July, but at the county level, and now showing the maximum temperatures or the average high temperature on the left, but the minimum temperature or the average low temperature on the right. And so if you look at the left, some of these peach colors or light blues, but not a lot of the dark oranges or reds that would show some of the extreme high temperatures. It actually looks pretty moderate when we look at our maximum temperatures. But then on the right, in contrast, our minimum temperatures, that dark red color for a county shows that it was the warmest July on record looking at low temperatures. And so Southeast Missouri, Southern Illinois, Indiana, Ohio, and a lot of Kentucky saw their warmest low temperatures ever in July. And I put a couple of articles here. This was definitely part of the headlines we saw, that it's been a muggy summer. And really, these maps kind of show a proxy for how muggy it is, because when we have a lot of moisture in the atmosphere that makes it feel humid, that tends to moderate temperatures quite a bit. And so it suppresses our daytime high temperatures, but also keeps our lows from falling too much overnight. And so the humidity definitely shows up here in these maps. But we can also directly measure our humidity and compare it to normal as well to see just how muggy was it. And this is over the past 30 days. And this map is produced using a data set called GridMet. GridMet uses station observations, but then it interpolates those, fills in the gaps, and combines with model data where it needs to create a nice continuous map here. And what this is showing is, for the past 30 days, the mean dew point temperature difference from average. And if you note here, the entire central region, with the exception of Wyoming and Colorado, had those dew point temperatures that were anywhere from a few degrees to maybe up to 10 degrees above normal. So, and this was really concentrated in parts of the Western Corn Belt and up into Minnesota and farther west as well. So muggier than usual for a lot of the region. And looking at states and different sites, there were many different records broken, whether it was high dew point readings or sustained readings of long periods with high humidity. It's been a record-breaking summer for that.
Hey, Zach, could you explain could you explain what a dew point is real quick?
Yeah, great, Doug. So we usually hear, and I've been mentioning humidity here. We didn't just look at relative humidity, because that won't show us as much, because that really depends on the temperature too. But what the dew point shows is the lowest temperature before condensation is going to occur, because the air can't hold any more water. So typically, as our temperatures fall to the night, they fall to that dew point temperature, and then you would see dew. And so the higher the dew point temperature, the more moisture is in the atmosphere. So it allows us to directly measure that here as a better metric than that relative humidity. So yeah, thank you, Doug. That was a good point there. And so some of this humidity comes from outside of the region. Some of it affects from the Gulf of Mexico, for example, but a lot of this humidity is due to, we've had a pretty wet growing season, and for most locations that continued here in July. And so here are our statewide precipitation ranks. The green colors show wetter than average. The tans are a little bit drier. And for the whole central region, only Colorado was the state in this region that had below average precipitation. Everybody else was closer to normal or wetter than average. And so we see the two most notable states here in the center of the region. Iowa recorded its second wettest July on record, and a lot of that precip moved east into Illinois, and they recorded their eighth wettest July on record. So ample precipitation for most here in July. And if we take a look at counties, we do have a few that broke their all-time record for July precipitation, kind of in that same area. 4 counties here in Iowa and 3 in Nebraska as well. And now let's look not as much just at July, but over the past 30 days. This is our percent of normal precipitation during that time frame. You certainly see in the same areas we were just looking at, Iowa, Illinois, getting into the Dakotas and Minnesota, that rainfall is really kept up here in August. But there's also a lot of red on this map showing less than 100% precipitation or drier than average. Some notable areas are really most of the western part of the region here in Colorado, western Wyoming. But then there's also, outside of some scattered dry pockets, a new area of dryness emerging in the east here, where we see all this red in southern Missouri, Illinois, Kentucky, and even southern Ohio as well, where we're starting to see more short-term dryness here. In addition to that, these are our temperatures over the past 30 days. For most, and especially in the eastern half of the region here, we continue these above average temperatures, excuse me, and we see these red colors showing anywhere from 2 to 5 degrees above average over the past 30 days. And that's very notable because late July to mid-August is climatologically our highest temperatures of the year. So you add above average temperatures to that, and it can feel pretty uncomfortable with the humidity too. A little less warm to the west, and in fact, getting closer to the Canada border and into some of the mountains out west, some cooler than average temperatures during this period as well. Now, we've been talking a lot about heat and humidity, but we do have 1 month until the next webinar. And so it may seem very far out of our minds right now, but I do want to show that just looking at climatological averages, we're really not too far away from seeing that first frost or freeze in the northern parts of the region. And so here's just one county in Michigan in the Upper Peninsula, Iron County. Average first date that the temperature falls below 32 degrees. September 14th. So maybe this time next month during the webinar, we're talking a little bit more about this, but we also might have a shot of cold air coming in here pretty soon that will feel a little bit more like fall. And so in response to temperatures and precipitation, how is our soil moisture for this time of year? And on the top left is a map showing from the Climate Prediction Center a model that's depicting our calculated soil moisture percentile. So comparing the current soil moisture to the soil moisture data for this day of the year and that location to kind of compare to those normals. And what we see is no surprise in the western parts of the region, so Montana, Wyoming, and Colorado, where we had seen that dryness, we have dry soils and in some cases, some of the driest soils on record for this model in particular. Farther east, we then see the impacts of the rain, and these dark greens show very wet or close to saturated soils in a lot of locations. And then pretty normal soil moisture getting into the southeast part of the central region. I do want to highlight, though, we see in that same area where precip has been a little bit lower over the past 30 days, the soil moisture models are starting to indicate some drier conditions there. And this might be more easily seen here on the bottom left, where we look at the soil moisture anomaly change from the last day of July. And so we see where some storms have moved through. We have some greens, added moisture to the soils. But I think the bigger takeaway from these changes is this broad swath from Kansas up through Ohio, where we are losing soil moisture for this time of year. So something to watch there. And then to kind of compare our model, these are the USDA NASS statistics showing for each state the percent short to very short soil moisture reports for topsoil. Again, in these wetter areas in the upper Midwest and the Dakotas, for example, you're not going to find very many soils with short moisture here, but you do see high percentages of short moisture in the western part of the region, and also getting into the Missouri and Ohio valleys, maybe because of some of the short-term dryness we've seen. And the drought monitor really resembles some of the soil moisture data we were looking at quite well here. And this is the most recent drought monitor map for the central region that was released this morning at 8 a.m. Eastern here. And first, I'll draw your attention to the western part of the region where drought is most severe. And so we do have the red color showing D3, which is extreme drought in Montana, Wyoming, and Colorado. And in western Colorado, on that western slope there, we have D4 exceptional drought, which is the most severe drought category used by the drought monitor. And so conditions are pretty bad out there where we have these extreme and exceptional drought categories, but not so much the farther east we go here. And so looking farther east, some spotty drought in South Dakota and Nebraska, and then getting farther into the Missouri and Ohio valleys. But for sure, right now, we think the highest drought severity is in the western part of the region. But the good news is, with all the drought-free areas, if we compare today, where 35.5% of the region is at least abnormally dry or in drought, well, that's way better than the start of the calendar year, when nearly 70% of the region was classified as one of these categories, or 1 year ago when 50% was abnormally dry or in drought. So relative to what we've seen recently, doing pretty well for drought status. And so we can see a lot of these areas that we've been mentioning here. This is the 4-week change or basically 1 month change in drought status. And so thinking about those categories where you see varying shades of green, those are improvements where you've improved by one or more category on the drought monitor status. And then we also have degradations where things get worse and become more severe. And so we see some improvement actually in some of the worst areas here in northwest and eastern Montana, but things getting worse in Wyoming and Colorado. Some of the splotchier drought to the east were improving in Nebraska, South Dakota, and Illinois, but then adding some drought here that we've seen recently in the Missouri and Ohio Valley. So kind of a mixed bag on the direction of drought depending on where you are in the region. And then just for fun, looking back to this time at exactly last year, a lot of flip-flops in conditions. So looking at the same areas in the West that are the worst right now, a lot of them weren't dealing with drought or very severe drought last summer. So we've gotten a lot worse. Meanwhile, we had a lot worse drought in eastern Wyoming and Montana. That's improved. That's a similar case here in Kansas and Ohio, where we had exceptional drought at this time of year last year. The only areas that are doing worse at this point, besides the western part of the region, parts of Missouri and Illinois and Nebraska as well. And then putting all that together, we've looked at precipitation, soil moisture, drought status. How's our hydrology and stream flow across the region? It's a mixed bag, just like the drought status. And so this is the 28-day stream flow map from the USGS and really follows the drought monitor pretty well. So we see below normal flows and even some record low flows out in the west where we have those drought conditions. The green shows normal flows relative to this time of year. And then, of course, where we've seen our heavy rain here, we do have some much above normal flows and even some river flooding in southern Minnesota, eastern South Dakota, and getting into Iowa as well. But really the only areas where we're seeing those low flows are in drought areas. And looking at kind of the entire basin here, some dryness in the lower Missouri, some mixed conditions in the upper Missouri, wet in the upper Mississippi, and kind of normal around the Ohio. Put all this together where the Ohio River meets at Cairo, and we see here our river stage in the red line for 2025. And we also see these kind of olive blocks here that show the average. This is the time of year our large rivers typically decrease in flow, so that's normal. But we'll have to make sure we stay in this normal range and don't dip below like the last couple of years where drought conditions have really reduced that stream flow. So something to keep an eye on as those flows decline with the season, whether we can stay normal there. So that kind of gives an overview of conditions. And now I want to move into impacts. And it really has been what seems like a busy past 30 days across the region. I'll start in Wisconsin, which has had an active period. This is in Door County, Wisconsin. And there was widespread tree damage here from a severe weather outbreak, doing a lot of damage in an area that's big for tourism this year, which is very impactful. But I think the biggest Wisconsin event was probably the Milwaukee flash flood from August 9th to 10th. And so I'm going to show some information on this slide and next. This is from a great write-up the Wisconsin State Climate Office put out about this event, but it really shows just how rare this much rainfall in southern Wisconsin is. And so on the left, you can see where this heaviest rainfall did occur, just north and west of Milwaukee. But look at some of these 24-hour rainfall records that were set. And these aren't station records or daily records. These are all-time one-day rainfall records for the entire state of Wisconsin. And we see that 4 of 7 of those were actually set just from this one event here. So really remarkable, topped out here in the city of Butler with an observation of 11.64 inches. And so, of course, this caused a lot of flash flooding across the metro of Milwaukee. The picture on the left is the exit you would take to get to the Milwaukee Brewers Stadium. And so tricky time to get off that exit. And in fact, this flooding did impact a couple of their games, although they were able to get those in. Unfortunately, wasn't able to get the last day of the state fair in, as this was from Saturday night at the state fair, and you can see the parking lots starting to flood and resulting in them needing to close the state fair a day early here in Milwaukee because of this flooding. So very impactful event there. But really, this entire area that we've been looking at that's seeing all this heavy precipitation has also seen some of these flooding events. And so here's in Iowa, a different fairground. This is the county fairgrounds in Ames, Iowa. We see inside and out some flooding in that area. Along with these flooding rains have also been severe weather, particularly in the northern part of the region here. This was from a derecho that moved through Iowa. Didn't cause widespread damage to crops, but we did see from these pictures corn that's laid over from those very strong derecho winds that we can see during the summer months. And then I'll move east into Illinois, where a lot of this rain's being sent as well, and look at a couple different events because it seems like it's been the summer of flash flooding in the Chicagoland area. This was the first one that really occurred over the past 30 days. And on the left, you'll see our rainfall totals very localized. We go from around an inch here in downtown Chicago to up to 4 to 6 inches in this kind of red blob here. Now, looking at the Milwaukee event, these totals might not seem as extreme, but I want to note that these are 2-hour rainfall totals. So 4 to 6 inches of rain falling in a very short amount of time, causing flash flooding. So this was a very, very rare and impactful event. On the right kind of gives us an idea of just how rare it is. And so these are, for a 2-hour rainfall event, what's called the annual exceedance probability. And this just means based on our distribution of historical precipitation data that we've been keeping record of, what are the odds of us seeing this total in this amount of time? And where those heaviest rain totals occurred, anywhere you see pink, gray, or white, for example, that's a greater than 100-year 2-hour rainfall event. And in fact, we kind of topped out here in this white grid cell where we did see 1,000-year rainfall event for 2 hours. So very, very rare to see there in Chicago. Then, more recently, about a week ago, a more widespread multi-day rain event for the same areas. And so here we see some similar totals to the 2-hour, so up to 6 inches, and it looks like the highest total was 8.54 inches, but a lot of this fell in areas that were already wet or had seen flash flooding earlier this summer. So we did see impactful flash flooding there as well. So a couple of events to note in Illinois. And then kind of to round out our flooding and severe weather tour, we'll go to Lincoln, Nebraska. And on the right shows a combination of local storm reports, which are the kind of animation figures there, and then the numbers, which are high wind gusts, which were observed. And I kind of zoomed in here just to show very high wind gusts, up to 80 or 90 plus miles per hour in metro areas. So Western Omaha and in the Lincoln area. So you combine a strong damaging wind event with some vulnerable areas and urban areas to hit, and there was quite a bit of reports of damage from these winds. Probably the most notable is this picture on the left. This is the Nebraska State Penitentiary in Lincoln, and the roof was lifted off by the damaging winds. And so a lot of work to try and get that back together. But you know, pretty interesting to see that damage on what's a pretty sturdy building to see there. And with all the flooding and severe weather, I did just want to zoom out to a national perspective and just show the map on the left. This shows the number of severe thunderstorm warnings over the past 30 days. You can barely see a few red dots that are tornado warnings over the same time, but look how many of these orange boxes that were individual severe thunderstorm warnings were in the central region here. And so a lot of the thunderstorm activity really concentrated in the region and up into the plains, which is pretty common for this time of year. And we have had quite a few flash flood warnings as well. And so we see those here, but also spread out a little bit more across the entire US, but still a very active past 30 days. Now on the dry side, we're also seeing some impacts too. So not everyone is seeing flooding and severe storms. And in fact, that exceptional drought and extreme drought we talked about in Colorado has led to Colorado's worst fire year since 2020. And this shows the map on the left, the drought monitor from last week, and then some current active wildfires from August 20th. And so we see these same dry areas in Colorado, Wyoming, and Montana are also seeing active wildfires because of the dry conditions leading to fuels. And so active firefighting going out in these areas right now. And here we see some firefighting helicopters leaving from the Mesa County Sheriff's Office there. So definitely seeing a fire season out to our west. Now compare the map on the left, which shows active fires in the US and Canada. So we see these same fires in the western part of our region, but now look at how many more fires there are to our north in Canada currently as well. And so this has all resulted in, especially the farther north you go into the upper Midwest and high plains, a lot of hazy, poor air quality days because of that wildfire smoke. And so this picture is from St. Paul, Minnesota. I know they've had a lot of problems with air quality, and in fact, a long streak with air quality alerts because of that. And most of this smoke continues to come in not from the western United States, but from Canada. So whenever we get northwest or even northeast winds, seeing some of that smoke come down, reduce visibility, but also it's unhealthy, especially to be outdoors for long periods because of that wildfire smoke. So seems like we've seen this the past few summers, but definitely over the past month, especially farther north. And looking ahead, we know we've got some drought to our west. What does the wildfire outlook look like? Well, this is for September on the left and October on the right from the National Interagency Fire Center. And I do want to note, we're just really focusing on Wyoming and Montana. Because of that drought, the western portions are highlighted for September as above normal for wildfire potential. Now, it is important to know that in this part of the country, they do have a normal wildfire season, so this would just be more amplified. And maybe where some recent rainfall fell here in the green, see for a short time a little bit below normal fire potential. But then we move to October and that risk subsides. So we may still see some wildfires because of a natural season, but not an above average risk like we see here for September. And now let's talk a little bit about drought impacts. And I've already shown this map, but now I want to kind of zoom in on where are the impacts we're seeing from these drought conditions. And so on the left here, we've got fire risk out to the west, but of course, that dryness is also impacting the landscape. And so here's a picture from Liberty County, Montana, showing a small pond going dry there. But I also want to talk about areas farther east that we haven't mentioned as much. You know, these patchy areas of drought. So starting in South Dakota and Nebraska, still seeing some impacts there. And so we're seeing dry grasses, stock ponds also going dry there. The picture on the bottom left out of Gregory County, South Dakota, shows cattle out to graze, but a pretty brown landscape. And it looks like they're going to find that greener pasture there, but definitely drought visible from the landscape there. And even in these small pockets of drought that don't look like much, still having some large impacts. So Michigan specialty crop agriculture, for example, has really taken a hit from just this D1, D2 drought here. We know that 40% of the tart cherry crop is currently estimated to be lost. Smaller blueberries are being seen in a shorter picking season, so less productivity there. And already in August, starting to see mature trees dropping leaves as well. So even in these smaller areas that aren't as extreme, still seeing impacts. And then I'll come down closer to my home state where we've talked about emerging short-term dryness. And we definitely have some flash drought emergence in Missouri, Illinois, maybe even southern Indiana and Kentucky. Now, flash drought is like flash flood, meaning it occurs much quicker than a normal drought event. And while there's not a singular definition for flash drought, when we mention this, we usually are talking about conditions deteriorating in a number of weeks compared to months. And so this area, you know, a lot of these spots, we're having one of the wettest years of record from southeast Missouri into Kentucky. And now they've rapidly transitioned from wet to dry. And this report here from Ozark County, Missouri, is what most of the southern half part of the state looks like. You can see it really drying out, and we're starting to see some agricultural impacts from that flash drought. So kind of a new area we'll be keeping an eye on with those emerging conditions. Now, not everywhere has had bad agricultural drought impacts, I do want to briefly mention again all of the white on this map. So roughly 2/3 of the region that's not abnormally dry or in drought has been pretty uncharacteristic for the past 4 years or so. And so this is an analysis that shows something called the NDVI, which is the Normalized Difference Vegetation Index. And all this is basically a satellite product that's looking down at vegetation and trying to detect how green it is. And based on a long-term record of these observations, we can compare our NDVI greenness to average. And so this graph here is averaged for every state in the region, and it shows our 2025 NDVI compared to the normal based on 2001 through 2023. And you can see we were coming back a little bit more towards normal right now, but since July, we've seen our greenness, or the amount of growth, be much more than average. And that makes sense with all of the precipitation and moist soils we've seen, as well as those warm temperatures. And so how are crops doing? Pretty good. These are our corn conditions right now, and you see the percent good to excellent, a lot of green on the map here. And so especially in the heart of the Corn Belt, we see Iowa, for example, 86% of that corn rated good to excellent. And compared to last year, that's the number underneath in brackets. If you're in the western part of the region, much better corn crop than last year. But then if you look basically from Illinois on east, a worse corn crop than last year at this point. So kind of a mixed bag, but overall good condition. And then a mixed bag on our progress too. So this is the percent that are at dowing stage, some above a little quicker than normal and green, a little behind normal if you get in Nebraska, Iowa, and farther north, but more of a mixed bag and no one too far behind or ahead on corn progress so far. Soybeans are a similar story across the region. Conditions are pretty good right now. Same story with the condition, though, as far as in our region, where farther west we have a better soybean crop this point from last year, and then Illinois on east, a worse soybean crop. So the western part of the region is definitely having a little bit better of a corn and soybean year. And then we see another mixed bag as far as the progress, although I do want to note here that the soybeans are pretty well behind here in South Dakota, 12% behind that 5-year average for progress. But overall, good news for soybeans. But I do want to note there's been a lot of moisture, and just like it's uncomfortable for humans to have all that humidity, there have been some disease issues in agriculture. This is a picture on the left you might see around the region, really up close on corn plants here, that rust color. That's a disease called southern rust, and this is a brave field agronomist from Iowa State Extension that went out in that field and actually came back with that rust on her here. And so very prevalent across the region, and that's a disease that thrives with moisture, but we're also seeing some other diseases as well. So maybe the only negative from all the rain that we've received. And then finally, no surprise that our pasture and range conditions currently are doing pretty well. So especially in the central part of the region, all of this rainfall has helped our pasture and range. We do have some dryness out to the west and maybe more normal pasture and range in the eastern part of the region. But overall, a pretty good year for growth, although there has been some issues with hay production based on some of that moisture. And then we'll end our impacts here with a look at the Great Lakes and really a couple takeaways. Number one, with warm air temperatures, it looks like we've also had a lot of warm lake temperatures. And so here we see all 6 of the Great Lakes reporting warmer than average temperatures for this time of year. We can also see the Great Lakes water levels here, which are kind of a mixed bag depending on which lake, whether each are above or below normal. But maybe the most notable thing we're tracking right now in the Great Lakes is in particularly the warm temperatures in Lake Erie. And so on the bottom left here, this orange line shows our lake surface temperature throughout the year compared to all the previous years. The warmest year since 1995 was 1995, and we're pretty close to that record. So very warm waters in Lake Erie, and because of that, starting to see some harmful algal blooms and even a loss of oxygen from the water. As we see on Monday, there was a hypoxia forecast for some of these algal bloom areas. So keeping an eye on that in the Great Lakes for sure. And so let's end here looking ahead at some outlooks briefly. I will start by showing the 7-day precipitation forecast from the Weather Prediction Center. And these are our forecast totals throughout the next week. And really, not a lot of rainfall expected for most of the region unless you're in southern Wyoming, Colorado, or southern Kansas, maybe southwest Missouri. But in these areas, we are expecting quite a bit of moisture. It looks like some monsoon moisture coming up from Mexico here, working into the Four Corners, but then also starting to move east and drop a lot of rainfall. So from the Rocky Mountains east through Kansas, these are forecast totals of 2 to up to 5 inches over the next week. And for this time of year, in most of these places, that's at or greater than your monthly average rainfall. So a lot of rainfall coming at once, although I will note with the fire activity and drought, I think Colorado, especially the western part of the state, hopefully will benefit from some of this rain. And then we'll look at our 6 to 10 day outlook that'll take us through the end of August here. And on the left shows temperatures, and we're almost guaranteeing below average temperatures for the Missouri and Ohio Valley in that 6 to 10 day outlook. And so you can see this bullseye in the eastern part of the region, a little bit warmer temperatures in the forecast for western Montana, but most of us are going to see a big cool down and see some highs in the 60s to 70s and lows getting into the lower 40s and parts of the area as well. So a fall air mass moving in here, and we can see the 6 to 10 day also picks up that slug of precipitation that we just saw in the 7-day precip forecast. And then moving into the 8 to 14 day outlook gets us into the start of September and Labor Day. That cold air sticks around, a little bit lower probabilities for below average temperatures than at the 6 to 10 day, but still likely below average temperatures for kind of the same areas here in the central region. So do expect this cool weather to last here for at least a couple weeks or so. And then we also see in the 8 to 14 day outlook, maybe some of that relief as far as precipitation continuing. And so areas in our region highlighted for probabilities of above average precipitation include Kansas, Colorado, Wyoming, and Montana, who will gladly take that if it materializes. A slight chance of below average precipitation getting over into the Great Lakes there. And with that 8 to 14 day precipitation, this is kind of in between the 6 to 10 and 8 to 14 day periods, but they do highlight, especially for our area, southern Kansas and into Missouri, a moderate risk of heavy precipitation, so where we might see hazardous precipitation causing flooding. And this will be something to keep an eye on, as Kansas certainly doesn't really have major drought concerns, and so we could see some flooding, but Missouri could use some of the rainfall, and so we'll need to keep an eye on the chance for heavy precipitation. And then we'll go here to end on really the extended outlook, and this is the 1-month outlook that was released today by the Climate Prediction Center, valid for September, and nearly the entire continental United States, minus a sliver in California, favored for probabilities of above average temperatures. Not very strong confidence in the eastern part of the central region. Our probabilities ranging from 33 to 40% of above average temperatures, but much higher confidence the farther west you go in seeing those warmer temperatures here in September. Now, looking over at precipitation, not as optimistic of a forecast for some of those ongoing drought areas in the west, as they are kind of a bullseye here for higher probabilities of below average precipitation in these areas that are dry. And even though it's kind of a lower confidence, we do see some drier conditions favored into Kansas and Missouri as well for September. And then the seasonal outlook actually looks pretty similar, and both the monthly and the seasonal kind of favor what we might expect for a La Niña during the fall months, and I'll talk a little bit about that on my next slide. But again, similar story. Most of the U.S. is expected to be warm this fall, and then in our region, the farther west you go, the higher those probabilities and confidence in warm temperatures are. Although I will note the Canada border, equal chances for either cooler or average temperatures. And then the precipitation again looks similar to the forecast for September, but September through November, we might see that move a little bit farther east with those probabilities for drier than average conditions. So we'll have to keep an eye on the potential for drought to move a little bit farther east. And so I mentioned La Nina, and that's important because El Nino and La Nina is a system called ENSO, and that's one of the dominant factors we look at for seasonal prediction. And so currently we have neutral conditions, meaning that El Nino Southern Oscillation is normal and that Pacific sea surface temperatures are close to average. But you'll notice here we have a La Nina watch, and that's because we're expecting, forecast models are expecting Pacific sea surface temperatures along the equator to start to cool, and cooler sea surface temperatures indicate those La Nina conditions. And so this bar chart here shows the probability of either La Nina, neutral, or El Nino conditions. And so you can see right now, July, August, September, we're in neutral conditions. So that's our highest probability. But by that fall period, La Nina becomes the dominant probability, and not by much. There's still a 40% chance, for example, of neutral conditions, but that's why we are in this La Nina watch, is that's what's predicted to happen this fall. But then we look ahead and a lot of uncertainty there. So by the start of 2026 here, we see that back to El Neutral or La Nada, we might call it, or neutral conditions here, over 50%. So not a lot of confidence that when it occurs, this La Nina would last very long. And this is one of the Climate Prediction Center's models they look at to try and predict those sea surface temperatures. This is the climate forecast system. And all these lines here, they kind of look like a spaghetti plot. Each line is a different model and what we call the ensemble. And then here, this dotted black line is the mean here. And important to note is that the threshold we look at for La Nina is a 0.5 degrees Celsius below average. And you can see most of the models do have us going below that threshold, but then quickly returning above it. So most of these models are showing similar guidance that maybe a short, weak La Nina could be in the forecast. And so right now that means a little less confidence in our ability to get farther into seasonal forecasts, like looking for winter, as we really need to see how these sea surface temperatures shape up. And so in summary, after a big cool down in the east over the next couple of weeks, it does look like above average temperatures are going to be the story late summer and fall. La Nina is the question. We'll have more confidence when we have a better idea on what these sea surface temperatures are doing and how long we can expect that La Nina to last, particularly throughout the winter seasons. When we're thinking about drought, I think in the near term, hopefully some of this significant rainfall does less flooding and more drought improvement out into the west, but we're also keeping an eye on flash drought here in the Missouri and Ohio valleys. And overall, good year from crops. Definitely some issues with heat and humidity maybe on crops and hay production, but does appear to be on track for a good year. And so with that, I'll list some contacts here. Myself and Dennis and Doug, also Brian Fuchs from National Drought Mitigation Center, and Brad Rippey from USDA. Please feel free to reach out to any of us with our contact information here. If you have a question about this webinar or have a question about anything climate related or agriculture related in the future. And I'll end here with a final picture taking us all the way back to Missouri. This is one I took last Saturday in beautiful Rocheport, Missouri, and you see the Missouri River flowing down here pretty much at its banks in a beautiful scene. So with that, I'll end there, and hopefully we have plenty of time for Q&A.
Thank you very much, Zach, for that extensive talk on so many different things. Sorry, I got something in my throat. We have one question that immediately came up in the chat. If you do have any questions, put them in the Q&A section if you want to ask something. But they were asking about, I think it was one of the flood pictures that you showed, and you may want to go back
and get pulled up here.
Yeah, and they were asking what the values of the AEP, or were the return frequencies determined from Atlas 14 or something else?
Yes,
Atlas,
that's a good
yeah.
question. I'm not sure, Doug. So this came out of the National Weather Service office out of Chicago, and I'm not sure if they flipped over
Oh,
to Atlas 15.
well, it can't be 15 because we don't have numbers for that.
So these are
Yeah.
likely then probably the Atlas 14.
Yeah. So we'll say yes. Um, okay. So you pulled it off a Weather Service website, huh?
Yes.
Okay. Okay. Um, yeah. So I think there were any other questions in there, Dennis, that you saw?
No more yet.
Okay. So if you have any, go feel free to ask them. I think there isn't other than crops are doing pretty well, and we've had a hot but fairly productive summer, if you will, as summer's kind of, if you will, winding down. The big news is really well, is this easterly flow and then northwesterly flow that we're going to be having, bringing a lot cooler temperatures in. We don't really see at the moment any chances. I guess there's always a chance, but the probabilities are pretty low for freezing temperatures or anything like that. Um, and quite a bit of rain across Kansas and in Colorado, which is some of those places really need it. Some of them don't. It probably will cause some flooding, as Zach was mentioning as well. Um, Anything else we want to talk about right now, Dennis? La Nina is a kind of a nothing Nina. It's pretty weak as it starts anyway, as we're going to get into that season in the fall. We'll talk more about that in September and in October for sure. The repercussions of what that means.
There is a question in there now, Doug.
Do you want to do it? I have to find that again.
Okay. What's the record dew point in the Midwest? Had a 75 Fahrenheit dew point here in the Chicago area.
Yeah, that's a good one. Oh, the record. What is the record dew point in the Midwest? Well, so I just saw a news report. Somebody in Kentucky, I think it was at a university, measured 83 in Kentucky. That's I don't know what the actual limit is in terms of those things. There may not. I'm sure there is one, but I'm not sure what it is. But anytime it reaches near 80, you're getting close to record.
Zach,
Any
do you know any in Missouri?
Yeah, I'll add in that we had one weather station, a mesonet station, record 84-degree dew
Oh,
point, and that was confirmed by National Weather Service AWAS station nearby, and that was the highest I've seen in this summer in Missouri. And yeah, I would agree, Doug. 84 seems about as high as you can go.
there's lots of physical reasons for that. It's hard to breathe sometimes when you go out in that kind of weather. I've noticed, at least for me, it is. Um, Now those types of oh, we'll get to the corn sweat in just a minute. Dennis or or Zach can answer that question because they've done plenty of interviews. Um, there are places in the Middle East that are next to the ocean that get tremendously hot, in the hundreds, and their dew points, because they're right next to the Red Sea, or yeah, Red Sea, or I can't remember the name of it. I'm losing. Anyway, next to the ocean, that their dew points get incredibly hot, and
Near the Persian Gulf.
yeah, Persian Gulf, and it feels like it, according to the way we calculate heat indices, feels like 150 or something like that, some incredibly hot number. Okay,
And
yeah,
Doug,
go
do you
ahead.
want me to take that one and then lead into the corn with the dew point there?
Yeah,
I'll
yeah,
address that a little bit.
yep.
You will see some discrepancies sometime between stations. Part of that, and Kevin addresses, some of the microclimate issues. Where is the station sited?
Mhm.
The Mesonet station that Zach mentioned, and I think might have been the Kentucky one, sometimes are in more rural areas and they are near agricultural fields. So the dew point measurement might be slightly higher because you are near a field that is actively transpiring and adding moisture to that. There are some differences that you'll see in stations sometimes too at airport weather stations, because there's the ASOSs, which are National Weather Service, and AWOSs, which are not Weather Service, are maintained by state entities, and they're slightly different in how they measure the dew point. We're getting into kind of geeky sorts of things here, but certainly this plays into the situation we're dealing with. We've had a lot of moisture and a lot of southerly flow from the Gulf, bringing up a lot of moisture. And then we have lots of crops that are actively transpiring, putting moisture into the atmosphere as part of their growth at this time of year. They have lots of water to work with and the soil moisture, and they're in good conditions. So and when we've had this heat, they're transpiring a lot of moisture. So that's why we've had this persistent period of very high dew points, very humid conditions.
And by many measurements, some of the most most moist air that we've had, at least over a period of time, that we've ever seen. Okay, let's go to, does climate drought include things as groundwater recharge? If so, could you include that for us? Yeah, that's a good one. Great question. And I'm assuming what you'd really want to know in this case is how much is the groundwater recharging because of too much or long-term drought in which you would not have a lot of recharge versus a lot of heavy rain in which you may have groundwater recharge. It is such a complicated question for so many reasons. So in states like Nebraska that measure their groundwater pretty carefully, and especially with the sandhills and such, they keep very close tabs on that. That might be some data we could get scraped from them. Other states are less. Some states are as good as Nebraska in terms of watching the groundwater recharge and all that. It's not something we often include because there are so many different layers and so many different areas of ground, if you will, and depths at which recharge happens. It's a really a hard puzzle to put together. Dennis or Zach, I think Missouri also has a pretty good groundwater system.
Yeah, we do, and I think this is a good question because groundwater is certainly a piece of the puzzle for drought, and even in Missouri where we have a lot of groundwater wells. A big problem we see is that we don't have a lot of historical data, which is making it hard to contextualize the groundwater. And then what makes it, especially farther west in the region too, it's not just groundwater's response to the natural hydrology, but also human impacts from irrigation as well. So adds another kind of complexity to what Doug was mentioning as well.
Indiana is another state that they do have active monitoring and report. It's not only monitoring, but it's being able to get access to the data on a real-time basis. That their weekly drought discussion does include a discussion of what groundwater levels are like, but you also need to know the local information about what is happening to groundwater. I think I've seen those two states called out as Indiana and Missouri being the two that the data is most readily available. So.
I am gonna pose, because someone mentioned corn sweat. So let's talk a little bit about that and try to, at least with this crowd, whoever's left, nullify the wording of that and change it to vaporization or something like that, or as our good friend Justin would say, breath. Do you want to handle the corn sweat? Either one of you want to deal with the corn sweat mention? You started to, Dennis, and there's a certain time of year when the crops really take over the evapotranspiration equation, if you will, as opposed to the Gulf of Mexico. Do you want to talk a little bit more about that and why we get so many questions about corn sweat every single summer?
And Doug is correct. The proper term for water being released by a crop or any plant does is called transpiration. It's part of the photosynthetic system that the stomates in the leaf release water while they're taking in oxygen or taking in carbon dioxide, or then they release water and oxygen. Corn and soybeans, corn is always mentioned. Soybeans are very effective at this also, especially in around August. Very effective at releasing amounts of moisture into the atmosphere, which make air around them very humid if you've been in a cornfield or a soybean field. But it is not the predominant, what we're experiencing is not all because of corn or soybean transpiration. It is, there is a large amount of background moisture that is brought up from the Gulf of Mexico that varies by time of year. And it's just, we add more moisture to that by transpiration of corn and soybeans and any crop, any growing actively plant. So corn sweat is what it was labeled, but it is transpiration is the proper term, and it happens from any plant that is growing. Zach, go ahead and add whatever you want to that.
Yeah, thanks, Dennis. The only thing I'll add in addition is there's a lot of questions about how much is the plant transpiration contributing to how humid it is. And you guys can add your thoughts too. I'll just mention that there's still a lot of uncertainty in that because it's difficult to measure transpiration and separate it from evaporation. And then it's even more difficult to measure or model how much of that goes into the atmosphere and what happens at that point. So a big uncertainty, and I don't think we can really give a great answer on how much plant transpiration contributes to that humidity.
We can measure minimum temperatures, and because there is more moisture in the air, most summers, now we are seeing increases in the minimum temperature, and this was one of those years that was I won't say off the charts, but certainly at the top of the charts in terms of how much moisture resided in the air, especially overnight. So our minimum temperatures, when the temperature goes down in the middle of the night, it didn't go down as far. There's a physical reason for that. It's called latent heat and all that kind of stuff, and that, if you will, traps heat in the lower atmosphere anyway. And so that's why your minimum temperatures are so warm, if you will. And a warmer world allows more moisture to be evaporated and transpirated, for that matter. Okay, I think that's it. Yep. Catherine is mentioning evapotranspiration in forest fires and drought connection also. Yep. So I think that's it. I see people are, Justin saying an 86 dew point at Boone, Iowa on July 27th. I hope that wasn't an AWAS site. So it's hard to measure dew points, and some places have better detectors, if you will, than others. And there's lots of articles there if people want to read more about groundwater monitoring. And thanks, Chip, for your humid day article as well as that you put in there. So I think on this note, we're going to say thank you very much to Zack for his great presentation. And we'll see you next. And thank you to Dennis for his comments. Thank you for Tanya for running the show at the National Drought Mitigation Center in Lincoln, Nebraska, University of Nebraska. And that's it. And so we can shut her down and see you next month.